Hello everyone and welcome back. Today we have 446 Arithmetic Slices 2 Subsequence, and this is a hard problem. It says here, given an integer array nums, we are to return the number of all arithmetic subsequences of nums. Okay, so now there's two parts. It has to be arithmetic, which means it consists of at least 3 elements, and the difference between any 2 consecutive elements is the same. So at least 3 elements, meaning there's at least 2 relationships. Okay, so for example, these all have a difference of 2, so this is valid. These all have a difference of 0, also valid. These all have a difference of -4. And this has various differences, so this is not an arithmetic sequence. Now, for the second part, subsequence means that we can remove some elements and possibly none, but they have to be in relative order. And so we are creating, from the input, we are generating all the possible arithmetic, meaning all the differences is equal. This one difference is 2, this as well. Here the difference is 0, and they are in relative order. So the main idea is that we have 2 relationships that we care about. And as long as we have at least 2 relations with the same difference, which means there's at least 3 numbers with 2 matching differences in relative order, then it qualifies and we can add it to the count of total qualifying sequences. So note that I emphasized the 2 relationships part a few times. So the main thing will be we're tracking the first relationship, and whenever we hit the second relationship onwards, we're going to say, okay, it qualifies, and we add the count at the first relation, at the start of the relation. I think in this instance, the code is actually clearer. So let's try that. So first we want to grab the total number of elements, and we're initializing this to 0. And we want to hold, because remember, we want to track the number of matching relations at that index, and we want at least 2 relations. So let's add default dict of int for in range of n. So for every index in nums, we're going to have another dictionary, which is going to track the difference. The difference will be the key, and then the value will be the count of relations up until that index that has the same shared difference. Okay, and then we're going to say for end and range from the second element onwards, because we want at least 1 relationship. And then for start in range of n. Okay, so if we find the relationship here, and that is repeated at the start, that means we have at least 3 numbers or 2 relationships, and it qualifies to be added in the result. So first, let's track the difference. The difference is whatever is at the end minus whatever is at the beginning, because they have to be in relative order to be considered the subsequence. Okay, and then whatever the case may be, we want to log that at the index ending at wherever our end is, which begins at the second number, for the key diff, which is the difference between the end and every starting value in the range of the numbers up until the end, we're going to increment by 1. And the reason we're incrementing and not setting as 1 is because if you look at the second example, at every instance, the difference is 0. So if we're starting at index 0, 1, 2, the difference between 0 and 2 is 0. The difference between index 1 and 2 is also 0. So for that reason, we want to increment by 1. And then say, now if this difference, which we calculated, which is the difference between the value at the current index and whatever start we happen to be on, if that difference is also already previously recorded in our DP at that starting index, that means yes, we have at least two relations that are matching. Okay, so we have some difference between their current number and all the numbers we're starting from in the range of the current number. But if this difference is also in the start, because remember, once again, we're tracking the total count of relations with a certain difference that ends in that index. So if this difference is also in the index of start, then we can add to our result whatever is log so far at that starting index. And then, because going forward, we want to be able to, collect the counts from the indexes so far at that index, we also want to increment it in here. So here we go. And then at the end, we can return the result. So first, let's make sure that that is not missing anything and that there's no syntax errors. We can submit. And there we have it. And then reviewing it one more time. Now, remember, the key here is that we care about three numbers. There has to be three numbers minimum, meaning that there's a relationship between the first and second number and another relationship between the second and third number. And there may be additional numbers. And for that reason, whenever we are iterating the range of every number, we're tracking the difference. However, we're also checking, have we encountered this difference before at the starting index? So if we are at, let's say here, and the difference we have between these two is 2. 8 minus 6 is 2. Cool, we'll increment that. However, at the index where start is, so we're at end is 8, start is 6, 0, 1, 2, this is the index. At this point, do we have a count of relations where the difference is also 2? Where the difference is also matching the difference between these two? We do. We have two other numbers that end that have a difference of 2 that ends at this index, because we're carrying over when we have a match. So this is the way, and yes, we are returning the count. We're not collecting the subsequences, we're returning the count, and that is how we're doing it. Thanks so much. Once again, this is 446 Arithmetic Slices 2 Subsequence. Happy coding. See you next time.